In section 2.3, we're looking at deductive reasoning. Now, deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to form a logical argument. And a logical argument is a key thing we're going to see in this class. As we move forward and start looking at proofs, proofs are really essentially a logical argument. We can't take it as an inductive reasoning, which we look back in section 2.1, which again, specific examples, patterns, observations we make. They're nice because they let us form a statement, but that deductive reasoning lets us form a logical argument, and that is really what a proof is going to be. We have to have reasons, we have to have steps that are facts, like it says, facts, properties, definitions that we have established to form that argument. It looks like it isn't a reason. One specific example isn't a reason. We have to use these rules that we have to form that logical argument. We're not going to get into proofs in this section, but we need to get at least used to that process, the thought process we're going to have. So the first law we actually have is the law of detachment, and that says if the hypothesis is true, then the conclusion is also true. And this we get from a conditional statement. And the conditional statement is of the form, if A, then B. And in these statements, if A, then B, the A is the, if A, then B, the A is the hypothesis, and the B is the conclusion. And so what this is really saying is if this statement is true, we can guarantee this part, then the conclusion is also true. So let's look at a couple examples. We have to change them to that if-then form, but if this part is confirmed, the conclusion will be true. So first we have Mary goes to the movies every Friday night. Let's write that as an if-then. So if it is Friday, then Mary goes to the movies. And if we look at that, this is the hypothesis, it is Friday. Mary goes to the movies is the conclusion. So, kind of ignoring what's going on with this statement. Just by up here, we've changed it to the if-then. Now, by this law, if this part is true, then that part's true. So, if we reread it, Mary goes to the movies every Friday night. Today is Friday. That tells us that Mary goes to the movies. Now, that is our valid conclusion we could make. Now, if you're looking at it saying, well, that's obvious, well, what if we knew it was Thursday? If all we knew it was Thursday is, well, we know that's not Friday, so then we can't make a conclusion that she goes to the movies. We really don't know either way. So if it is Friday, though, we can confirm it. Valid conclusion would be Mary goes to the movies. So if we look at it mathematically, if two segments have the same length, then they are congruent. Well, we know that BC equals XY, or their lengths are equal. So they have the same length. Our conclusion would be that BC is congruent to XY, that they are in fact congruent. Now, to look at the other direction, maybe we didn't know they were the same length. Maybe this has a little slash through it. Then we can't say they're congruent. So this law just sets it up so we can use that law of, or we can use the conditional statements in our problems. Now, next one is the law of syllogism. And if we look at this one, it says, if hypothesis P, then conclusion Q. If hypothesis Q, then conclusion R. And that leads these two statements combine to give us one new one. But let's ignore those statements and see what's really being used here, which is P, Q, and R. So I'm saying if I have P, then Q. Second statement, if I have Q, then R. And I can see a logical process going. We've started at P, and we ended at R, and that's what those statements allow us to say. Now, realize we could plug in different statements in for P, Q, and R, but it's really that setup that's occurring. If P, then Q. If Q, then R. Now, what this law lets us do is instead of writing out all the steps, we can then just say if P, then R. So we're going to say hypothesis, P, then conclusion, R. And what we've really done is kind of cut out that middleman. Q was in both of them. It was kind of a link between P and R. It allows us to just say hypothesis P, then conclusion R. If I number them, I took statement 1 and statement 2 to get to statement 3. Now, if you're still a little lost in the letters, this example kind of helps us put it together. If Rick takes chemistry this year, so that's what we've started with, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. Now, notice Jesse being Rick's lab partner is a link between the two statements. He takes chemistry, Jesse's his lab partner. If Jesse's his lab partner, he's going to get an A in chemistry. Kind of with that process we have up here, we can now just shorten it and say, if Rick takes chemistry this year, then, well, Rick will get an A. So by taking out that middle step, we can shorten it up. Yeah, that middle step was we needed it to get to the final result, but we can shorten by this law and make it one statement. And this approach of using these steps and then condensing it down is something we're going to see throughout proofs. It's not going to be something we'll explicitly use, but it's that thought process of working through them. And same with the law of detachment. Key thing to remember whenever we talk about deductive reasoning, besides these laws, is that we're using facts, definitions, our properties, laws of logic, which are ones we talked about, all to form a logical argument. Each step, each statement has to have a reason that we can use it.